very last session of MA 2005 PTP for the semester. Okay. Welcome. Yeah. So for today, I'll be going through 4C, and after that, I'll be going through this question. This is I'll be going through this question afterwards. 2018-2019 semester 2, the angle question. Yeah, true angle question. I'll be going through that later. But first, I'll be going through 2020-2021 question 4C. So I assume all of you can access the cheat sheet already. That okay, like shortcut method thingy. Yeah. Like you can refer to it as you do and remember the steps are okay. So okay, let's go to solve the question. So generally the first thing I want to do, you can fill in these squares first. So these squares are just the average of these values. Loading. Yeah. You can see it's so you can see here 85.796 plus 85.704, right? You divide by 2, you get 85.75. And since they tell you to run off to 2 decimal places, right? You leave it in 2 decimal places. So yeah. Okay. That's the easiest thing to do first. And that will give you 4 marks. Yay, 4 marks. How easy. Yeah. So then the next thing you do according to the paper, right, is find the positional tolerance. Now what is the positional tolerance? So how to say positional tolerance, right? It's actually quite a complicated like topic, like idea. So you see these two values, like yeah, you see the values here. You take the difference of these two, right? And you can plot it and you take the difference of these two. Okay. If you didn't know, the two outside dimensions, right, refer to the pin, this thing. Then let me just draw first. Yeah. So the blue matches with the blue and the red matches with the red. Okay. So what does it mean by positional tolerance? Okay. I assume you all know what's a vertical tolerance band, but basically it's the difference between the top value and the bottom value. For this case, the top value is 78.496 and the bottom value is 78.404. So and if you plot that into an equation, right, you just get let me just write it down. 78.496 minus 78.404 n squared. Okay. So if you recognize this equation, right, you're technically just doing Pythagoras. So Pythagoras, right? Positional tolerance is like how much you can shake like diagonally. Like it's that sort of idea. Like I don't want to go too deep to it will get quite confusing. But just think of it as like the Pythagoras of the tolerances. So and the horizontal band, okay, the blue one, so it's 85.796 minus 85.704. Then square. Then you just plot that into a calculator. Yeah. It'll be nice if you do it with me, then you can get real-time practice. 0.794 minus 78.404. Then 85.796 minus 85.704. then you get 0.1301. Then you round off to 2 decimal places, you get 0.13. Yeah, you get 0.13. And then, okay, so that will be your positional tolerance for the 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 light blue. Oh, sorry if I wrote in the wrong pen, but yeah. So you can write here 0.13. Let's take a calculator on school. Calculator. Yeah. Scientific. Okay. So then you get 0.13. Then for the bottom one, right? Yeah, it's the same method. So I'll just use a red pen this time so it's clearer for you all. So 50. I'll just type in the calculator. Okay. So the whole thing will be square root. Wow. Actually, this is never mind. I'll just write it down. Okay, 52.686 minus 52.614 in square, then plus 46.386 minus 46.314 in square. And you get your other positional tolerance. So square root 52.686 minus 52.614. And Pythagoras of 46.386 minus 46.314. Oh. 36.666 minus 52.614. Do double check your values, because if you get it wrong, right, then like you're gonna lose a lot of marks. So if I'm not wrong, okay, this should equal to 0.1018. Then if you round off, 0.10 lah. So 0.10. So 0.10. And that's how you get 6 marks for the last question. See? 6 marks. You can get 6 marks in around 5 minutes. Okay. Okay. Now for the harder part. Then where the majority of your marks will come from. So okay. Okay. If you look at the past year papers, right? As you can see, there's the A, B, C here, and here there's a A, B, C, right? If you go to the past like OO papers, they actually left it blank. Load. Yeah. They left it blank. So if they left it blank, right? Just fill it up. So as you can see, you refer to here, right? 0.6. Okay, you fill that in. Then A, B, C. I just fill in A, B, C. Or if they gave X, Y, Z also. So you see these 3 datums here, A, B, C. Yeah, just fill in A, B, C. Okay. And something that was phased out, but I guess you can bring back every time, right? Is the letter inside the small circle. So okay, as you can read from this paper, what year is this paper? 2016, 2017. Quite an old paper, right? It says respectively in any direction from their true positions when both are at their M and C, maximum material conditions. So both of this will be M. Yeah. Then I go to another year. The more recent papers don't have it. So for this, right, you see LMC, it'll be L and L for each of the circles. Then in the more recent years, he phased it out. Yeah, he filled it in. So M and L. Yeah. So yeah, if LM. Don't worry about feature control frame. It's just the letter in the so the feature control frame for the top one is M. Feature control frame for the bottom one is L. Let's see if even older one. Yeah, so that's all lor. He kind of removed some marks from here because he didn't require us to fill in the holes, the blanks anymore. But if this year he decides to do it, you know what to fill in. Okay, so that's like 1, 2, 3, 4, 5, 6 marks gotten already. Okay. I'm not really sure about the marks like split, but maybe this is 1, then maybe this is 2, and then each one of these are 2. Let's add up. No. Okay. Kind of ends up. Yeah. I guess 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See, you got, if you fill in the entire top half, you get 8 marks already. So yeah. Okay, now for the harder part, the bottom half. Wait, I'm in the wrong paper. Yeah. Okay. So now that you've gotten 8 marks, now time to get your other 8 marks. Okay. So as you can see from here, hi, what about the what do you mean the modifier? You can just speak into the mic. Hello. Hello.
Hi, hello.
Yeah.
No, I no, I just want to check about the tolerance modifier, like the M and L. Like, how do we know whether is it like M or L? Yeah, just a quick one. The
Oh,
tolerance modifier. Yeah,
the thing in the circle, right?
yeah, yes.
Um. Okay, I thought I said it already, but he kind of phased it out. But like as you can see here says MMC for both, right? Hello.
Yes.
So both the circles are MMC, like the will have the letter M.
Oh, okay. Thank.
Then this paper should be um both L. Yeah, you can see here. I did this. Yeah, both are L.
Okay.
Yeah.
I understand.
Okay. So yeah, gotten half of the question already. So now to get the other half of the question. So hole and boss are at MMC. Pin is at LMC. Oh no, what should I do now? Okay. So what you do now? Don't panic. Okay. So you can refer to this sheet first, but do try to remember it by heart by the time the exam comes. So okay. Step 1. Okay. Okay, step 1. Okay, so now refer to this, right? Minimum D1. In this case, what is D1? D1, right, is the top of the okay, this is a pin in the hole, by the way, if you're not sure. That's why you can see the small gap here. It's a pin that's resting in the hole. And this is a boss. So it's just a piece that's sticking out. So right, what they want you to find for the first half is the top of the pin. So as you can see, the pin is smaller than the hole. So it's like resting at the bottom of the hole. And so you want to get the smallest distance from the top of the pin to here. Okay. So what do you do now? Okay. One thing to take note, right? The moment you fill in this, right, this shit, right, you can kind of ignore the top half already. Because when you do GD and T, right, for 4C, you know how your positional tolerance, you use these values, right? When you use your positional tolerance for the second half, it kind of takes into account the tolerances here. Not sure is it. It's quite confusing, but you don't have to care about the top figure anymore. Like just ignore it. You can fold your paper in half and just focus on the bottom half. Yeah. You use simple numbers now. Yeah, 2DP is the way to go. Okay, in this case. So okay. So D1. What is D1? D1 is here. So here is D1. Okay. So minimum D1. If you remember from last week, right? We did the shaft thing. This shaft. So what we want to do is shift things around, but within tolerances. Yeah. Within acceptable tolerances. Okay. So what is D1? D1 is top of the pin to the top of the boss. So to make D1 smaller, right? To make D1 smaller, right? You want this to be at its bigger size. So 36.45. Yeah. So you want this to be bigger. So it goes up a bit. Then yeah, goes up a bit. Then you want the top of the pin to be you want the pin to be smaller. Oh. So hole and boss are at ALMC, pin is at MMC. Okay. So now we move on to the next step. So they tell you that hole and boss at LMC. So I'm gonna write that down first. So don't forget. No. LMC. No, for the first two is you'll take the bottom one. Yeah, if there's a dash there, you don't have to do it. Okay, so I'll do the bottom one first. So hole and boss are at MMC. So let's go to the hole. Okay. So what are the dimensions of the hole? 48.25 plus 0.34 minus 0.11. Okay, so hole boss. Okay, hole is at MMC. So that for MMC of the hole, right, maximum material, you need a smaller hole. So in this case, right, you'll take 48.25 minus 0.11 equals to 48.25 minus 0.11 equals to 48.14. Okay, 48.14. Is it visible? Okay, I hope it is. 48.14. Yeah, so that's the, let me write it at the correct location. So, hole 48.14. So that's the smallest hole, MMC. Okay, now for the boss. The boss are at MMC. So for boss, so maximum boss is you can think of a boss as a shaft. So maximum boss is just 36.45 0.13 goes to 36.58. Yeah, if you can do this with me, it'll be more beneficial. Then okay, so pin is at LMC. So you got pin now. Pin, the pin is a shaft. So pin, MMC for a shaft is just a small amount. So it's just 47.75. Okay. Okay. At this step, right, if your calculator can save values, I heavily recommend you to just save them all into your calculator. Like, yeah. Because you'll be using these values a lot. 47.75. Point seven. What? 47 point then 5 minus 0.003. Oh, that's annoying. 47.474. Okay. So for me, I like storing them in like A, B, C. Yeah, I just store them in my calculator. I think most calculators should have that function, but if you don't, just type down the number every time. Okay, so now what we want to do. Okay. Minimum tolerance modifier. Okay. Okay, 0.2. Okay. So now what we want to do is minimum D1. Okay. So smallest D1. How do you get the basic dimensions for D1? You just take 78.45, right? And you minus 52.65 goes to 78.45 minus 52.65 equals 25.8. So 25.8 is this distance. Okay. So please take note, right? This distance, right? It's not to the center of the pin. Yeah. I should draw the arrow a bit higher. This distance, right, is to the center point of the hole. Okay. I think wait, so here. So you see this this thing, right? This dimension here is to the center point of the hole. The pin is because the pin is smaller, it droops. It's like it drops in the hole, as you can see from this gap here. So the center point is slightly lower. Like we don't know it now, but we'll find out later. Okay. Okay. So okay, now for the I would say confusing part. So okay, if tolerance modifier matches material condition, carry on as usual. If different, add tolerance band into positional tolerance calculation. Okay. So as you can see here, right, pole at MMC, tolerance modifier at L. Okay. Now what does that mean? Okay. Let me write down the equation first. So if you not sure, you can refer to this for the 2018-2019 Sem 2 minimum D1. This is the 2019-2020 Sem 2. Yeah, one year after. So it's kind of the same. Yeah. So, okay. So now we got this value, right? Which is 25.8. That's not really visible. But okay, 25.8 is that distance. Now let's add the boss. Carry on as usual. Okay, so you see the boss, right? Okay, you see the boss is at M. It's at M, and here boss is at M. So you can just add the M of the boss. So let's see. Hmm. Okay. Actually, right, I'll go according to what I write on the cheat sheet. Cause yeah, how to say? Okay, I'll explain to you the cheat sheet way first. See if you all understand. If not, I'll go into the more how to say. You have to do two things at once. So you have to take note of the dimension and the tolerance at both times. But I feel that the cheat sheet might be easier to like handle a cheat sheet method. Because as you can see, I handle both the tolerances and um the dimensions differently. Okay, so according to the cheat sheet method, right, what you want to do is 25.8, right? So minimum D1. Okay, so minimum D1. So what you want to do is minimum, right? So you minus the tolerances. Because how to say tolerances, that means you can move 0. like 0.3 up diagonally like diagonally. So you want to half that. So half. So in this case, the pin, right? The pin is L and the pin is L. So you just say 0.13. Pay attention to here. It'll update. Okay. So 0.13. Then you add here is 0.10. So 0.10. And does the material condition match? The boss is M. Boss is M. So it matches. Yay! You don't have to worry about much. So okay. Then this will equals to 25.8 minus half, right? So 0.13 plus 0.1. Okay. Then you get 25.658. 6685. Okay. Now for the last step. So for the last step, right? So you take the value that you got, 25.685, right? Okay. So how will you shift this 25.8 into D1? So what you want to do, right? You want to move it up and how to say? Okay. What a lot of people don't get, you can't just move from, let me zoom in. Okay. Yeah. Draw. Yeah, I'll just draw it. Mouse. You can't just move from here to here. Because this doesn't have a value, or this doesn't have any value. You know why? Because this is the, make this thinner. This is a lot thinner. Erase. Okay. So right, this is the center point of the hole. This is the top of the pin. You don't have a dimensions for that. So you'll have to go the long way around. So you have to go down. Okay. Right? Then you go up. Okay. Then for the bottom, you go up. So an easy way to think of it is up is negative. Oh, okay. Don't think of it as that. Okay. So then, okay. So what you want to do, right, is you don't take 25.8 lah. You take the value there, 25.685. So 25.685. So you want to minus half the pin. So after you minus half the pin, you'll be here, right? Be at the bottom of D1. Okay. Then you minus half the hole. So after you minus half the hole, you find this distance. Then you add the entire pin. So you go up by the pin. Then you get your D1. Is that confusing AF? Y'all can understand? Like you're just shifting the 25.85 into here, but you don't really have a value for this to this. So you need to go the long way around. So you go down by H, hole. You go down by the hole, then you reach here. Then you go up by pin. Then you'll be at D1. Great. Okay. Okay. So I hope you saved it in the calculator. But okay. So what you want to do, right, is zoom out. Okay. Okay. So we settle the boss first. So you minus half of the boss. Okay, minus half of the boss. Then you minus half of the whole. Minus half whole. Then you add the pin. You plus pin. Okay. Then you get answer. So in this case, 25.685 minus half of the boss half of the boss minus half of the whole, then plus pin. Okay, this is the value I got, 31.072. So 31.072. And round your results up to 3 decimal places. Great. Okay, so that is your minimum D1.
Bro, can I interrupt you for a while?
Sure.
Okay. When we look at this tolerance for the whole, right?
Yeah.
Are we supposed to add the position tolerance and the tolerance band?
Oh, okay. That I mentioned just now there was 2 ways to think of how to do it, right? Like
Okay.
so this is how to say. Okay, this method makes less sense, but it's clearer. So you see how in this portion, right? I don't have to care about the tolerances.
Oh no, I'm actually looking at the second step.
The second
25.
step. Okay, yeah. So actually, right, these 2 steps should actually be together. Like they should be one combined step. But I actually worked together with the other tutor to like come up with this idea last year of splitting them up, so it's easier to manage.
Okay.
Because
No,
if you do together, right, it'll be very messy because you're dealing with a lot of minor signs and whatnot.
yes,
And
correct. No,
you realize that you really no when you do the maximum, right, you realize that why this step is more beneficial. So if I didn't split it out, right, your all this half 0.13, right, you have to include it in here also. And with
yes,
the
correct.
amount of negative signs you're dealing with, right, I mean rather not risk it, you just do it in 3 different steps. So
Um,
step 1 minus, step 2 you settle the tolerances. So after you settle the tolerances, right, you don't have to care about your whole boss and pin, like less room for error, so to speak.
okay. No,
So you don't
what
want
I want,
them together. Okay. So what are you asking?
no, what I was referring, because the requirement given that whole and the boss are at MMC, right?
Correct.
MMC.
Yeah.
And in our FCF,
Yeah. Feature
the modifier,
control frame. Yes.
yes, the modifier for the whole is actually is under L, list material.
Oh.
So that
Oh
part we
shit.
need to.
Wait. Pin. Oh no. Okay. I realized that wrong already. Sorry. Yeah. Okay, can correct that. Let me correct that right now. Okay. Thank you. So okay. Sorry for the mistake. So okay, L. So this is the whole. The whole is the L. Whole
Okay. Okay.
L, whole MMC. So you add the positional tolerance of 0.13. Okay. Then let me shit. Okay, wait. 0.13 plus. Okay. Oops. Let me rewrite this. This is like very wrong. Okay. So orange band. Okay. 13. So does not match. Yeah, give me a sec. Let's look through something. Okay. Okay. Let me see. Okay. So okay. Okay, sorry for the mix up. I see wrong. So yeah, L and M. So you have to add. So you have to do 0.13, right? 0.13. You have to add the 0.34 minus minus 0.11. So 0.45 plus 0.45. Then you add the bottom boss mm matching. So 0.1. Then you get 25.8 minus half. 0.13 plus 0.45 plus 0.1. Okay, 25.46. Okay, thank you for correcting me. Then as if just now, 25.46, right? You minus half of the whole plus in minus half of the boss. Okay. So minus half of the whole plus in minus half of the boss. Okay. So 30.847. 30.847. Okay. Yeah. So that's the correct answer. Okay. Sorry for the mix up. Okay. Now you have minimum D1. So maximum D1. Maximum D1, right? So instead of so the important thing to know, right? So actually all the steps are the same, but instead of okay, instead of this, right? Zoom in. This being a minus, right? Just a plus. You can see here. So if you do a plus, right? You get okay plus. If you do a plus, you get 26.14. Yeah. Then you punch it in here again. Then you'll get an answer. So yeah, then let me just minus half h. Minus half of the whole plus pin minus half of the boss. Okay. Then when it's a maximum, you get 31.527. So 31.527. Actually, a shortcut you can do, right, is you just take this amount, right? Then you plus what, 13? You plus whatever here, but just don't half it. I mean, that's a shortcut, but you can recalculate again. But honestly, you need all the time you can get. So you just, since okay, like, because this goes from a minus to a plus, right? You just add the difference, which is this. So 30.847 plus 0.13 plus 0.45 plus 0.1. This one will equals to 31.527. So this is a shortcut you can use, and I advise you to use, because like this method was designed like the 3 steps, so you can do minimum and maximum like quickly in between each other. You just add the tolerance, these tolerances without the half. Just add it here. Yeah, that's the shortcut. But the difference is just the tolerance spans. Okay, everyone can understand. Any questions before I move on to the minimum D2? Yeah, I'll just let you think of questions. In the meantime, I'll just okay. Oh no, I erase. Okay. In the meantime, I'll just write the thing. So whole and boss are LMC. So whole LMC this material so biggest. So whole will be 48.5 plus 34. 48.59. Okay. LMC. Boss at LMC is the biggest. So 36.45 plus 0.13 equals 36.58. No. Wrong. This is wrong. LMC for boss is the smaller one. So 36.45 minus 0.26. Okay, goes to 36.19. The pin is at MMC, so the biggest pin is 47.755. 47.755. So that's the biggest pin. Okay. So now you got your three values. It's the same calculation again. Okay. But this time they ask for a D2. So the concept is kind of the same. So you just you find somewhere to write. The first step is just 85.75 minus 46.35. Then you get 85.75 minus 46.35. That's 39.4. Okay. So 39.4 is this distance. Okay. And they want the side of the pin. So once again, right, there's actually a very small distance. Okay. There's actually a very small distance between the side of the pin and the side of the hole. Del X. Yeah, there's a very small distance between the side of the pin and the side of the hole. So it's similar to this. So right, to find the side of the hole, okay, we start with this. We are finding D2. So the first easy step you can take is you can add the boss first. So add the boss. Okay, now you add the boss, right? So what you want to do with this is you realize that the center line of the pin, right? Oh, can scroll down. Oh, I'm talking about this portion though, like this portion. Is it okay? Scroll down here. Oh, no, I'm explaining this now. Okay, so the center line of the hole will match the center line of the pin. Great. So all you have to do, right, is move left by half of the by the radius of the pin. So half a pin. Yay, half a pin. So okay, once again, minimum D2. You want to minus minus the positional tolerances. So let's move to here. Zoom out so you can see. My goodness. Okay. Okay. So what you want to do here, right, is settle the thing first. So hole and boss are LMC. So similar to just now. So you take 39.4, right? You minus half of the stuff. And what is the stuff? Okay. Hole. Okay, it has nothing to do with pin. Both hole and boss are LMC. So the hole is 0.3. So 0.3, you don't have to add the tolerance. Then boss, so 0.1. So since the boss is M, but here the boss is L, you have to add the positional tolerance, which is 0.39. Plus 0.39. Then you get 39.4 minus half, 0.13 plus 0.1 plus 0.39. You get 39.09. Okay. So 39.09. Okay. Then after that, you settle the this thing. So how do you want to do it? So 39.09 you plus half of the boss, half of B, then you minus half of P. Okay. Okay. So 39.09 minus no, you add half of the boss. So the boss is 36.19. No. Yeah, 36.19 minus half of the pin. Half of the pin is half times 47.755. Okay. Equals to 33.3075 equals to 33.308. So 33.308. Then to find maximum, you just add this one in. So plus 0.13 plus 0.1 plus 0.39. Then you get 33.928. So 33.308 plus 0.13 plus 0.1 plus 0.39 equals to 33.928. Yeah, and that's how you solve for C. Anyone needs like repeat or further explanation? Okay, satisfied? Okay, so if no one has any questions, right? Then anyone has any questions about part 3, like any GD and D portion before I go to angles? Those angles gonna be pretty hard. Yeah. I think I will have a hard time explaining also. Because yeah.
Kenny,
Yes.
could you repeat the portion after the 25.8? That's not a question.
25.8.
Could you repeat the step from there?
Oh, the why I minus half plus this.
Yeah.
Okay. So you don't understand it for this part also.
Yeah.
Oh. Okay. So you know what I said about the tolerance modifier matching material condition? Oh, you didn't catch it. Oh, okay. Okay. Hmm. Okay. So you can think of tolerance modifier as something you use to make it smaller, because you already you since you took the average, right, of the tolerances, like here is the average. Your tolerances, like the upper minimum and maximum, right, have moved to your this thing. So all calculations from for tolerances, right, will be using your positional tolerance. Okay. So like I would say this is more of like a shortcut, because the long thing will be, it's quite hard to explain and visualize. So for this, right, okay, for the second step, you don't have to care about anything else. You just need to care whether the material condition, Can't half scroll. Okay. So you just care about whether your material condition, right? Like for this case, hole is L. Like hole. Oh shit. Hole equals LMC. Okay. Hole equals to LMC. So hole equals LMC. So hole equals MMC. So there is a mismatch. So when there is a mismatch, right, you add the tolerance band. Okay, so tolerance band into positional tolerance calculation. Tolerance band stands for the upper minus the lower limit of the hole. In this case, the upper limit is 0.34, the lower limit is 0.11. So the tolerance band will be 0.45. Do you understand that portion?
Yep, understood.
This is like just a formula that it'll make it easier for you to calculate. Because if you have to do it the way that was taught in the lecture, right, you have to think about how each thing interacts with each. But me and the other peer tutor, right, we came up with this method. Like you just need to see whether they are the same condition, then carry on accordingly. Yeah. Okay. So you understand the second step already? Hello.
Again.
Okay, the third step is the third step fine for you? You're just shifting the stuff around. Just go up and down.
I think it's okay. I'll try the question, then I'll get back to you. Yeah.
Okay. Yeah. This one you should try. Like once you do it once or twice, right? You'll get a hang of it already. Every year's the same. So anyone got any questions? Before I move on to angle. Angle should be the
Okay,
hardest thing.
Okay,
Alright.
a quick clarification on the tolerance band.
Hmm.
The formula for the tolerance bands is the upper deviations minus the lower deviation.
Tolerance band. Yeah.
So since we
Or
have a negative, that's why we actually add up.
or you can just think of the spaces between, like
Oh,
I mean 0.34 to in between positive 0.34 and negative 0.11. What's like how many now? Like
okay, all right.
what's the
Really appreciate that. Really, thank you very much.
okay. So any other questions? Not angle. Angle's very hard to teach. Also, it's a very hard concept to grasp. All the true angles and stuff. Like it's a bit hard to teach. So if you have problems, right, it will be more effective to PM and I'll explain to you step by step. But I'll try my best now because it's a very hard topic that everyone screws up every single year because it's not very intuitive and it's a bit hard to explain. Yeah. So I'll try my best to explain, but don't be disheartened because it's a very hard concept to grasp. And because it's also not touched upon in tutorials, so that makes it like infinitely harder to grasp also. Actually, oh wait, I can pull out slides for that. Got slides for that. Okay, give me a sec. This is give me a search for the slides. Yeah, as you can see from this cluster of yeah. I'll just explain with the slides because I don't have the drawing materials right now. So okay, can this load? So this is 17, 18, Sem 2. Yeah. Should practice this at least once or twice. Because this is the killer question every year. But normally in Sem 1, they prefer to give the auxiliary B. Never mind. Never mind. Ignore what I said. Doesn't matter. The Sem doesn't matter. Yeah, okay. So actually never mind. You just go find the paper. I'll just refer to the slides. Okay. So if you can find the paper, 1718 Sem 2. Sem 18 Sem 2. Okay. Now you may be asking, what are these lines? What do they mean? Like, you don't understand. So basically, they are it's just a, okay. No, it's just a triangle with a stick going through it. So yeah. And you're trying to find the angle that the stick makes with the triangle. So imagine you have a piece of paper, triangle piece of paper, right? You got to stick a satay stick through it. You're trying to find the angle, the acute angle in between the satay stick and the triangle. Not very intuitive, but yeah, you have a stick through the triangle. And you're trying to find the angle. First, I don't think first angle projection matters. Like, it doesn't affect. Then yeah, looks like this. Okay. So, okay, step 1. Look at the question. So in the question, right, it looks like this. Nothing. And the moment you look at this, right, there's no lines parallel to the datum. So Lim Chun Sing, being the nice prof that he is, he gave you all these lines to follow. So you won't go out of the paper. I heavily recommend that you follow these datums, because if you don't, you'll probably go out of the paper already. Then okay. So step 1. Step 1, connect all the corners to each other. Hey, easy step 1. Okay. So you just take your ruler, connect all the corners together. A, N, N, B, C, M, N, B, B. Okay. So the next step. Oh, that's a very long next step. Okay. So, okay, never mind. There's actually an intermediate step that the slide skip. So, okay. Since they don't provide you with a datum, right? You have to make your own datum. And the datum you make it from the first view. So if you can see here, AD is the first thing. So you can see he wants to take you on a journey. So before you start your journey, at the first view, right, you create a datum A to an imaginary B that is parallel to X1, Y1. If you're all confused already, just sound out. I'll explain the next steps, because this is a very hard topic to grasp. So A, yeah, I can draw here. A, D. Okay. Then D you push down, so you will get a D here. And whoa, you have an AD, line AD. And remember your M3, when there is a datum, right? Like a line is parallel to a datum. So AD is parallel to X1, X2. AD becomes true length. Wow, amazing. True length. Yeah, AD is true length. Yeah, okay. So, okay, AD is true length. Now you go on true length. let's say on the front, draw a construction line AD, project D from FV to the plane view. And then you'll notice that this line will be perpendicular to y2 and x2 and y2. Okay. So now, I think a concept that wasn't mentioned, right, was that if you reflect a perpendicular line about a datum, so in this case, AD is perpendicular to x2 and y2, right? This point, how to say, this point, right, AD, right, will vanish. Right? Oh, that sounds so magical. But if a line is perpendicular to a datum, there's no way to show this, but if the line is perpendicular to the datum, right, in the second view, right, you can see here is A dot D, right? Both points are at this point. Like D is in front, A is like behind in 3 dimensions. So this one you have to think in 3 dimensions, like 3-dimensional manipulation. Okay. Okay. 3-dimensional manipulation. But yeah. Okay. AD. Okay. You'll note that CB is also not parallel to this line. NM is not parallel to this line. So there's nothing to work off. Okay. So you see here. Here. Okay. Okay. Now hapat. Okay. So okay. What you have originally, right, is these two views. These two views. Now, how do you know how far away, like how to draw? How do you know how to draw this view? Like how? How do you draw this view? So, okay, draw. So you see nothing here, right? Okay. Go back. Oh shit, go back. Alright. So the distances that you have to take note, right? Okay, let's call this, right? Since it's B, beta. The distance between B, this is beta, right? Beta. This is also beta. Yeah. By the way, these all red lines, right? All perpendicular to the datum. So yeah, the red lines are perpendicular to the datum. Okay. Then this is beta. Then you see M. M this. That's right, M, right? Small m. This is M. Okay. You see this small c here? Is this C. See this N? This distance. Oh shit. Okay. So in summary, right? The length for this one come from the one like before it. So you don't take the length from here. No. You take the length from here. Anyone super confused already? Okay, hello. Hello? Hello? Y'all can understand? Rang clear? All good, Siva, Raja, y'all can understand, right? Because you've been
so far so
actively
good.
asking me questions and like, yeah.
No.
This is a very complicated thing. I'm also worried because a lot of people screw this up because it's not taught in the tutorial. Like you have to figure this out yourself. Yeah. Okay. Now we move on to the next part. Okay. You see in the first one, right? You don't know where's the intersection. Like where does the line, like where do you poke the satay stick into the triangle? Okay, now we know from here. You realize that once you get to here, right, you have a point of intersection. So you can just go back. This is it's a perpendicular line, by the way. Perpendicular, right? Okay. You can go back. Oh, and you find out, oh, it intersects with here. Then you can fill in the line. Then yeah, you can fill in the line also. So yeah, you got your intersection. Okay. Now yes, okay, you reach the first auxiliary view. Okay. But the sad thing about this, you still don't have any true lengths. You just found a point of intersection. Okay. So now for the next step. Okay. CB reflect off this line. Parallel line to the datum. Yay! Now you get the true length already. So when you reflect a parallel length of a datum, you get the true length. So CB, you reflect. And remember what I said about the lengths? You take it from the previous drawing. So right, okay. So B will be a very short B. A, A will be a very long A. So okay. You see here, A is a very long A, B is B, because you're taking the values from the previous one. You see that the shape is kind of like here also. So remember it's point to point. So N will be N. So N around here. Okay, piercing point. Yeah, you realize that your N, right, will rest behind here. So it's like let's see here. You have to manipulate in 3D. I don't really know how to explain it, but you have to visualize it somehow. That the satay stick, right, is on the back side of the triangle paper, and like, oh, okay. Then you draw a dotted line for the satay stick. Okay. So, okay. A, B, C. They are all parallel with the datum, right? So once you reflect them off the datum, you will get the true shape of ABC. Yay! So the main concept I want you to grasp, right, is that when you reflect points, like ABC is all parallel to the datum, they will become true. It's a very important concept to know. You don't want to reflect too many times or so. So once you make it true already, right, don't touch it. Because if you touch the true and reflect it again, right, it'll become a perspective length. It won't be true length anymore. Okay. So now you got the true shape of ABC. Okay. Now to find true angle. Okay. The true angle, right? MN. Okay. You'll find out that Y4 and X4 is parallel to M and N. So, okay, remember, reflect the line, MN reflect off Y4, X4, right? Y4, X4, you'll get the true length. This is the true length. Okay. So, once again, this is the hella confusing part. Okay. The hella confusing part. Okay. Oh, and okay. So okay. This is not MN, by the way. This is B A. But right, A B C right, it's a flat triangle paper. So if you look at it from this side, if you look at flat triangle paper from this side, right, it's flat. Yeah, it's flat. Okay, so A B C is now a flat piece of paper. You're looking at the edge. You're looking at the edge of a flat piece of paper. Now recall MN. Yeah, MN. So MN, you take the values from here. So M is very long, N is very short. So here M is very long, N is very short. Okay. Now you got true length of line MN. You got the edge view of A, B, C, and this will be your angle, 67 degrees. Okay, anyone lost? Or anyone not lost? Yeah, anyone not lost. If you can grasp it, good job. If you can't, don't worry, that's like normal. Very hard concept. Most people get it wrong. You know? That's so good. I can understand. Wait, someone sent a message. Someone send a message somewhere else. Oh, good. Oh. Any questions? If you can't understand this, you can send me a message at another time. This is a very hard topic. But I think if you scroll through the group, you can see these slides again. Yeah, I said this quite early because I sent it with the entry slides. If I didn't send, you can remind me to send. Yeah. Yeah, there's questions like, okay. This is another one. Front elevation plane. So this is just a triangle. F, E, F, D, D, E, F, D, E, F. You're just viewing a triangle piece of paper in 3D space at different angles. Okay, great. Note that none of the lines forming the triangle is true length. See? None of the lines are parallel to the datum. So this is datum x1, y1. So just now, right, what would be the first step that you do? You make your own datum. This is quite an old paper, but now interesting likes to take you on a journey. So last time you actually had to plan about where your lines will go, but now he think got fed up, so he gives you all the datums. So what you want to do is D, E, F, G. So you make a datum that is parallel to here. Okay. So you get E, G. This is G. This case is a lot like the previous one. So true length, EG, then you get this line. So you get FEG, FED. Yeah. So FED is a true length line. If you didn't know. That's it's similar to just now. EG is true length, and when you reflect it off a datum, right? Everything was flattened. To explain this. Okay. If you can't really visualize it, right? Like try cutting a piece of like A4 paper into a triangle and like play around with it. It might be easier to visualize. because this is a very abstract topic. So GE, right, is true length. So we reflect GE of the perpendicular axis. F, E, D will all be in a straight line. You can do it like here. So you measure here, right? It'll be the same as here. You get a straight line. So don't worry if you get a straight line. It just means that yeah, you're going the correct way. So this is parallel. They reflect it again. So this is a straight line, and this will be true shape. Can you all understand this one? This is like this is the paper edge view. Edge. The view from the paper's edge. Oh wait, is it possible? Wait, when was this? Repeat from the second auxiliary plan to third auxiliary plan for the bottom one. Okay. Akash, do you still need the information? Hello? Okay. So to draw the third one, right? You're basically taking the dimensions from the first one. So when you draw the third, you take from the first. When you draw from the fourth, you take from the second. So B and B. You can understand that part? Oh, okay, great. So does that answer your question? Okay. Okay, to be honest, right, the best way to learn graphics, right, is you draw. Then if you get stuck, or you just try your best. Like, don't get stuck. If you draw, right, draw until you feel it's correct. Then you show me. Then I'll correct you. That's the easiest way to learn graphics. So honestly, if I keep telling you, right, no use one. You need to draw yourself. Then once you get satisfied drawing that you think is correct, just show me, then I will correct you. If not, it's very hard to learn. This, especially this angle view, this angle thing. Yeah. Actually, there's one more type of question for this. No, that should be all. He'll give you a triangle and you have to play around with it. So you create a parallel line. So step one, create parallel line. They have spelled parallel wrong. So create a parallel line. Step two, reflect. Reflect on why you pick McEnch as a major. No. Reflect of the datum. Okay. Reflect of the datum. Okay. Step three. Reflect of perpendicular. Okay, I'll go right there. Reflect of the perpendicular, right? Then you get a line. So this line is like true. So if you look at a piece of paper, like x1 and x1 and y1 datum given, no, it wasn't given for this year, but I think he will give datums for now. Yeah. If not, just draw it yourself. It's around the same steps. So you just want it to be perpendicular. It wouldn't make sense to make a datum here. Yeah. Because this will probably be at the edge of the paper already. So it's quite like, yeah, you won't draw a datum here because your paper doesn't exist in the fourth dimension. Yeah. Any other questions? If no other questions, go and practice your MA2005 because you too can get good marks for it. Don't need listen to the rest. The average, okay. I would say the average is low, but that was when there was no PTP tutors. Now you have 2 PTP tutors, so don't feel afraid to ask us about stuff. Okay, so anyone got any more questions? Email. Okay. Any questions? Okay, if no questions, I'll stop the record. This is all I have for y'all lah. I'll upload this video by tonight, so y'all can see it. Okay, recording.